Hello everybody, I'm Vivian Jennings, Autopilot Vessels Application Engineer, and here we'll be seeing a complete workflow of a pressure vessel from the modeling part, recalculation, reviewing the reports, and the drawing generation. During that process, I'll be giving some strong arguments on why Autopilot Vessel is the tool you were looking for all along. To create a new model, I go to the menu File, New. He's asking me what type of vessel I want to create. This one is pressure vessel, so it's fine. I just click OK. Now the templates appear. These are a starting point, a time-saving tool that will help me create a set of components with their own materials in the fastest way possible. I'm going to select a horizontal vessel with 2 saddles and a boot, and then Next. Now I have the full catalog of design codes at the top. I'm going to stick with ASME as proposed. Then the local loss method for my openings and nozzles will be WRC. Both flange standards are OK, and the bolt type will be UNC. Then my design method will be optimized. I will receive assistance from the software to figure out most of the dimensions. This is ideal for a first phase of design and also, of course, for a demo like this. Then I'm not going to go through all the fields, but if you ever have a doubt, you just click on the help button at the top and you click on the correspondent field. That will give you the answer and more information on that particular property. Now I close and I click Next. The code of colors of the fields inform me on what is essential for the calculation to run or the element to exist, like for the red fields of internal pressure and temperature. Then yellow stands for values that cannot be guessed, like the liquid height or corrosion, or even the external conditions like pressure and temperature. And finally, in green are all those properties for which there are default values or equations from the code. Now we click Next to land on the load conditions. As you can see, Autopilot Vessel automatically generates the load combinations for the lifting, erected, operation, shutdown, and test conditions. For this example to run smoothly, I will erase some cases, so I will just not compute the lifted, erected, and shutdown. If you see, depending on the case, different weights and surface exposed to the wind, known as load, will be considered. You can, of course, adapt it by checking and unchecking those options. In the operating condition, normally everything is activated. Now I only have 3 for my operating and test case. Then I say OK. And I click on Next. Then Next again. Here I can input the initial values of my templates, such as the diameter of my shell, the distance between tendon lines, so the length of my shell, the position of my first saddle, which is going to be 500, the axis ratio of my elliptical head, then the diameter of my boot, the length of my boot, and the location of the boot itself. By changing those values, I save a lot of time, then I just click Next. Here are different chapters of my report that I can activate or deactivate. Well, we are not in the report phase, so I will just click Next. And finally, the last dialog corresponds to the materials. Autopilot Vessel by default suggests to use the Division 1 ASME materials. Of course, you can have several groups. This is just a shortcut. I can always edit materials one by one. This is just a time-saving bottom. Okay, I will leave it by default using my ASME 8 Division 1 materials and then click on Finish by default. Here I have my initial vessel. Now let's do some changes. I'm going to split it in 3 parts. I'm going to change the diameter for the first part, edit, change body properties. I select both of them and I change the diameter to 900. This one will be a cone. align to the bottom, an eccentric cone. And now I will be adding a bolted cover with a body flange. I transform this elliptica head into a body flange. You can see that I'm not going to input all this information. It's just going to be a flat face, the simplest one. And the rest of dimensions, the software is going to figure them out for me. Then gasket. To change the flange material, I will just be using the default groups. So I select body flange, then apply, and you can see that my 4G material has been applied. For the bolting, I will be assigning it one by one. So I select bolting type, the class, the norm, and finally the symbolic name. That's the step-by-step procedure. Then I just click on OK. Now let's add a bolted cover. Now we need some nozzles. Insert. Let's call it A. It's going to be an inlet. 10 by 100. It's going to be up top, so 0. And let's add a stand-up flange. So flange, apply. Okay, material is going to be a nozzle neck, nozzle pad. Here are my local loads. Simply 100, 200, 50, and that's it. Let's duplicate it. I'm going to call it B. I'm just going to add it wherever because I'm going to move it to my final location. Now let's add some nozzle to the board. Let's call it boot. It's going to be at the extreme of the board. We are going to be having also a standard flange. But location, I didn't indicate a board. It's a fix, and here is like board. Now it's fine. Let's relocate the board using the move option. And I'm going to add a third saddle. So this one is going to be at 300. And let's add third saddle 2000, just what this one is. And we're going to fix the first one in order to have two saddles that are the same and one first saddle on a different diameter that is different. And with that, we'll just run it. Okay, so you can see that between with toggle, we can change from the input view to the design view. The red one is the design view. You can see that some nozzles have been added. There are two stiffening rings and at the small junction and the large junction of our knuckle. Also, the thickness of our body flange and bolted cover have increased. If you see the summary of changes, we just go to the summary of changes here, and we can see what it has done for us. Let's see the errors. The first one refers to needing a knuckle. According to this code, let's do it. Good. Now I'm going to ask him to, instead of using stiffeners to increase the thickness of the elements, I will also ask him to calculate it according to division 2 instead of 1. Then I run it again. Well, now I don't have the stiffeners. He has just increased thickness. As you can see here, I don't have any thickness at all. But he just figured them out for me. Okay, now let's see some reports. Here we have some calculations at internal pressure, nomenclature, all the intermediate values, equations from the code, and then the intermediate values, and finally the results, the minimal thickness that we were looking for. We can see them also for the different isolated openings. For example, for A, values that we use, the equations we needed, and the values from them. And if we go to the navigation pane at the left, we can see all the different chapters. You can also travel to the local loads. Having done that, let's see all the deliverables that we can generate. Because I'm happy with my design, I will create a bill of materials. I can see that my bill of material is here. All different components, its weights, and of course the description of the material. I'll close. Let's generate the 2D drawings and the 3D. And I will ask to generate the component drawings too. Great. Now I click on the eye to see them all together. Well, here is the last one generated, the components drawing. So you can see the drawing for each one of the components. Well, he assumed that my welding was at the top. I could, of course, change that. This is my cone with the 2 knuckles, development of the other shell, nozzles, they were piping, so we just have to cut the pad, the boot, the bolted cover, and the body flange. And you can see the others one here. This one is the 2D. We have the longitudinal view, completely with all its dimensions. The fixed saddle, the 2 sliding saddles, the summary of nozzles, 3 ones, transversal view. This one is my fixed saddle. Here were my sliding saddle. And of course, all tables that go with drawing that are completely customizable. So everything is customizable. You can change the order of the views, the size of the views, choose the views that will be shown, and of course, personalize it so that you have your company logo and your clients. Then let's go for the 3D view model. Just focus on one of them. Let's change it slightly. You can see if there were some internals, we would be able to see them. Now it's empty, so we just see the outside of it. You can have your 3D and your 2D in all different formats, WG and DGN, without the need of a third party, but you can also generate it in SolidWorks if you want to.
Wasn't it amazing? The drawing generation is just one of AutoPyVessel's strengths, along with the automated design that proposes you a solution that you can adopt fully, partially, or use it as a guide to understand your vessel's weaknesses. All that time, you will be helped by our high-quality, self-explanatory, step-by-step reports, and you will be able to do changes easily through our fast and intuitive modeling workflow. For more technical or commercial information, please use the link in the description. Thank you very much for watching.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.